Hi everyone, I wanted to show you an abbreviated truth table problem from 7.4x, and I'd like to do number 2. Let's take a look at it. This is what it looks like, and as we do whenever we do an abbreviated truth table, we want to make the conclusion false and all the premises true, or we want to try to if we can. Now here's the conclusion. It's if C, then not D or B. And I'm going to go ahead and put the false under the arrow there. And the three premises are, first premise right here, if B, then not C. Second premise is C and A, if and only if, not D. And the third premise is just A, all by itself. And so we're going to go ahead and mark those, each of those true. Now when we want to make the conclusion false, we notice that it's a conditional. The main operator in it is the arrow, so it's a conditional, and we know there's only one way for a conditional to be false. It has to have a true antecedent, so that's the C, and it has to have a false consequent, so that's the not D or B. And so we're going to put an F under the negation sign. However, if we want the not D or B to be false, well, that means that D or B inside the parentheses has to be true. And if it has to be true, well, there's three different ways it could be true. It could be true if D is true and B is true. But it could also be true if D is false and B is true, or if D is true and B is false. Now, just to speed things up a little bit, I'm going to select this whole line like that, and I'm going to copy it, and I'm going to paste it down on the next row. And I'm going to go down again and paste it again on the next row. Notice we've got three identical lines here, and we're just going to change those things in the consequent of the conclusion. We can make D true and B false. And we can make D false, and leave B as true. And that covers all the possibilities, whether D or B, which has to be true, can be true if they're both true, if D is true and B is false, and if D is false and B is true. Now, from this point, we've got to start doing some work and going back through the line and do that on each row, just to make sure if we can do this. Now, notice we've got C over here. C is true on every row. So we've got a couple of C's back here in the premises, and those are going to be true everywhere on every row too. More precisely, we've got not in the first premise, we've got not C. So for C to be true, that's going to have to be false true, false for the negation sign, and true for the C. And we've also got C and A as part of the second premise. And that's going to be true every time. Okay, is there anything else that we can determine right away? Well, yes, there is. We've got A. A is true in the final premise, So it's also going to have to be true when it shows up in the second premise. So we've got A being true on every row. Now, where do we go from here? We've got, let's take a look at the first row. On the first row, we've got D is true, and so we're going to go over here and we see, we've got not D, so that's going to be false true. And we've got just about enough to figure out the rest. We've also got B being true on the first row, and so we'll have to put that over here. And if you look, we've actually filled out the first row already. Does everything make sense there? Unfortunately, no. If B then not C, this first premise here is a conditional, and it has a true antecedent, B, and a false consequent, not C. And that means that you can't have a true conditional here. So that doesn't make sense with those truth values, but we don't have any other truth values to use on the first row. So we're going to have to put a slash here in place of this T. What about the second premise? We've got C and A being true. I left that out, but we can go ahead and do this on the other rows as well. And we've got if C and A, or not if C and A, C and A, if and only if, not D. Now C and A is true, not D is false, and that can't be true. You can't have a biconditional which is false or which is true when one side of it is true and the other is false. So we've got to put in a slash here too. And that's all on that row. Now we've shown that with those truth values, there's no way to assign it so that all the premises are true and the conclusion is false. But we're not done yet. We're not done yet because we've got to check for the other ways that we can have the conclusion be false. So let's go over here. On this one, we've got B being false. And so over here, we can have B being false, and that doesn't cause a problem. We've got false antecedent, a false consequent. That can be a true conditional. Do we have any problems anywhere else? Well, we've got not D. Well, in this case, D is true, so not D is false. And it looks like that has the same problem as on the first row. Namely, you've got a biconditional that's true on one side and false on the other. So we got to stick a slash in there to replace, oops, not a question mark, a slash. And now, what about the third row? Well, on the third row, we've got B being true, and we've got one of those true antecedent, B is true. We've got a false consequent, not C is false. So we've got to put a slash in there. And now it's pretty obvious what we're doing. It won't matter what else we have to put in. We're not going to be able to have any kind of assignment of truth values that will get all of them correct. So let's take a look at C and A. That's true, true, true. We've got over here, we've got D being true, so D being false, so that can be true false, and that doesn't cause a problem. But on every row we have at least one slash indicating an operation where you can't assign a truth value. So every possible way that you can have the conclusion be false, it's turned out that you can't have all the premises being true. And that's the earmark of a valid argument. And so we're going to hit the valid button, and there's the answer. We've shown that the argument is valid. There's no row with all the premises being true and the conclusion false. And that's how you do it. Thanks for your time.